In this video, we're going to discuss the derivatives of exponential and logarithmic functions. So we're going to add three rules to our derivatives list. The first rule is that the derivative of an exponential function e to the x is really just e to the x. The second rule, the derivative of some constant a to the x, so this is going to be a numeric value a. The derivative of a to the x is a to the x times the natural log of a. And then the third rule is that the derivative of the natural log of x is 1 over x. So let's look at how we can apply these rules. For example A, it says f of x equals 5x squared plus 3 to the x. So what we're going to do is we're going to take the derivative of each term. So the derivative of the 5x squared, that's actually coming from section 3.1, is 5 times 2 to the x to the 2 minus 1, plus we have this rule now. This is our second rule. This would be 3 to the x times the natural log of 3. So simplifying this other part, we'd have 10x plus 3 to the x natural log 3. And I'm going to put a little barrier here for part B. So same idea here for part B. But if you notice, we want to do something that's 1 over t before we start doing the derivative of each term. I'm going to say that's y equals 4t cubed plus 1t to the negative 1 plus 5 to the t. And the reason I'm doing that for that middle term is it allows me to use my derivative rules. So using the derivative rules, going through each term, we would say y prime equals, the derivative of the first term would be 4 times 3 to the t raised to the 3 minus 1, plus we would drop down negative 1 times negative 1 t to the negative 1 minus 1, plus this last part we can just do our new rule. That's 5t natural log of 5. So y prime would equal 12t squared minus 1t to the negative 2 plus 5t natural log 5. And the only thing I'd say we can do with this middle term, we can make that t to the negative 2 positive by dropping it to the denominator. So y prime equals 12t squared minus 1 over t squared plus 5t natural log 5. Okay? Alright, last one. f of z equals 3e to the z. So we're going to take the derivative of each one of those terms. F of z prime, I should say, f prime of z equals this term right here, 3e to the z. That's the same thing as just 3 times the derivative of e to the z. And from our first rule, the derivative of e to the z would just be itself. So that's actually just 3e to the z. Plus this 4 to the z would be our second rule. That's going to be 4 to the z natural log of 4. Okay, we had that other rule that the derivative of the natural log of x equals 1 over x. So we're going to use that here to write the equation of a tangent line. Y equals mx plus b. And we want to do this when x equals 2. So the first thing we need to find is m, which is really the same thing as f prime of whatever x value we want to use. So f prime of 2. To find f prime of 2, we first need f prime of just x in general. Well, if f of x is the natural log of x, then f prime of x equals 1 over x. So f prime of 2 equals 1/2. That is really our m value, our slope value. So y equals 1/2 x plus b. The second thing we need is b. To find b, we need to find an x value, which we know x is 2. And so we need f of 2, the original 2 value. This will really be a y value. So f of 2, well, if the function is natural log of x, f of 2 would be natural log of 2. And using your calculator, there's a natural log button. If you put in natural log of 2, and notice we said to 1 decimal place, the natural log of 2 to 1 decimal place will be 0.7.